we've reached the last section in this unit, and the I can statement is I can factor expressions using rational numbers. So we've been doing a whole bunch of different things with rational numbers, and now we're ready to tackle factoring. So as a reminder, we've got a couple warm-up questions here. What is a factor? So stop and think about what a factor is. And a factor is part of a multiplication problem. Part of a multiplication problem. So for example, if we had 3 times 4, the answer to that is 12. The 3 and the 4, those are factors, and the 12 is the product, or we could say the product of 3 and 4 is 12. So this is the product over here, 12. The answer is 12, and the two parts that made up the multiplication problem, the factors of 12, were 3 and 4. And then for part B, it says how many factors are in the problems below. So let's take a look at these problems right here. So this is 1/5 times 3x plus 2, and this is negative 1.5 times x plus 3. So if you're thinking in terms of how many factors there are here, there are 2 in each one of these. So this right here is a factor, and this right here is a factor. Remember, those parentheses group those two things together. So we've got a factor of 1/5 and a factor of 3x plus 2. We've got a factor of negative 1.5 and a factor of x plus 3 right here. So there are 2 factors in each one of those problems down below here. And then it says simplify the following expressions using this distributive property of multiplication. So here's what we're going to do. We are going to multiply through. We're going to multiply in here. So we're going to take that 1/5 and multiply it by 3x. So this would be 1/5 times 3x. And then this would be plus 1/5 times 2. So if we multiplied here, again, you might as well think of everything as a fraction. So we're going to multiply straight across. We're going to have a 3x on the top, and we're going to have a 5 on the bottom. We're going to have a 2 on the top, and we're going to have a 5 on the bottom. And we can write it like this. That would be totally fine. But a lot of times what we'll do is we'll slide those numbers out in front so we've got a coefficient. So we're going to write that as 3/5 x and then plus 2/5. So there's our answer on that one. And let's go ahead and distribute through here. We've got some decimals to deal with here. So this is just going to be negative 1.5 times x. So that's going to be negative 1.5x. Positive times a negative is negative. So we're going to have negative 1.5 times 3. If we multiply those, and you're welcome to use a calculator if you need to, that would be negative 4.5. Okay, so I'm going to circle that one right there. Okay, so as a reminder, a lot of what we learn in math is we learn how to do something, and then we learn how to undo it. We learn to do something, and then we learn how to undo what we just did. So we learn how to add, then we learn how to subtract. Those undo each other. We learn how to multiply, then we learn how to divide. Those undo each other. And in that warm-up question, what we did is we rewrote a multiplication problem as an addition problem or a combining problem. Okay? And we did that using the distributive property. Well, the opposite of that would be rewriting an addition problem as a multiplication problem. So if we distribute through, we rewrite it as an addition problem or a combining problem. And if we do the opposite, we'll be rewriting an addition problem as a multiplication problem. And if you'll remember, we call that factoring. And I mentioned when we covered this the first time that factoring is something that you've got to be really good at. It's never going to go away, and you never want to forget the first rule in factoring. So as a reminder, the first rule in factoring, expressions with more than one term, is to take out the GCF, take out the greatest common factor. And that was the type of factoring that we learned in a previous unit. So the second thing that we want to keep in mind is if distributing is multiplying in, then factoring is the opposite. It undoes that. So it would be dividing out. What undoes multiplying, or the opposite of multiplying, would be dividing, and the opposite of in would be out. We always take out the leading sign. So if it starts off with a positive, we're going to take out a positive. If it starts out with a negative, we're going to take out a negative. And if it seems like you can't take anything out, then you can always take out a 1. 1 is a factor in any multiplication problem. So if you don't think you can take anything out, you can always take out a 1. So we're going to take a look at these expressions right here, and we're going to factor those. So I'm going to say this a special way. So we're going to say this just as like if we were reading off fractions. So this is 3/5 x plus 2/5. And remember, the first rule in factoring is always to take out the greatest common factor. If we say this, now listen very carefully, 3/5 x plus 2/5, you can hear what the common factor is. You can hear that there are fifths in there. So we're going to take out a fifth, a 1/5. If I take out the 1/5, I'd be left with a 3 on the top and an x, so I'd be left with a 3x. If I take out the fifth part of this, I'd be left with a 2. So there's the answer right there. So I've got the 1/5 out front, and then I've got the 3x plus 2 inside parentheses. Remember, two terms here, we're going to have two terms inside the parentheses. I want to show you this a couple different ways. I can actually rewrite this and to show that we've got a fifth in there. So I can say 3 times 1/5 times x. So remember, a 1 is part of any multiplication problem. So if I just slide that 3 out front there, kind of think of that as a 3 over 1, I can see that that first term is a 3 times a 1/5 times an x. And if I do the same thing with this one, I can pull a 2 out there, and that would be a 1/5 there. So you can see that I've got a common factor of 1/5 here and 1/5 there. So if I pull that common factor out, I'm left with a 3 and an x, so there's the 3x, and I'm left with just the plus 2. There's one more way that we can show this. Remember, we're factoring out, so we're dividing out. If I take the 3/5 x plus 2/5, and I divide each one of those by 1/5, so I'll divide each one by 1/5. Remember, we don't divide by a fraction, we always flip that over and we multiply. So this is going to be times 5 over 1, and this is going to be times 5 over 1. So we're dividing out that 1/5, so we'll take out the 1/5, and then let's see what we're left with. Well, if I cross cancel the 5 with the 5, I'm left with just a 3x. And if I cross cancel the 5 with the 5, I'm just left with a 2. So there's the same answer gotten either way. So hopefully you buy that with a couple of arguments there. Now in this next problem, we've got negative 1/5 x minus 4.5. So we've got a decimal. For some reason these can be a little bit more difficult, but there's a little hint here. If you think about what these numbers would be if they didn't have a decimal, it might be a little bit easier. So I'm going to think of these as negative 15 x minus 45. So you'll notice that there was one decimal place on each one of those. So I basically just took the decimal off there, or if you wanted to think about it this way, I moved it over one place to the right. And so I'm thinking of it this way. I'm thinking of negative 15x minus 45. Well, the first thing you notice is it starts off, the leading sign is negative, so we're going to take out a negative. And then we've got a 15 and a 45. Well, if you think in terms of GCF, the biggest thing that can go into both of those is a 15. So I took out the negative and the 15. I'm left with an x. I took out the negative and I divided a 45 by 15, so that's going to be a positive 3. So this would be the answer if it didn't have decimals in it. Well, remember it did. Instead of a 15, we've got a 1.5, and instead of a 45, I've got a 4.5. Well, what if we just did this? What if we just take out negative 1.5? What if we put that decimal right back there where it was before? So that would be an x plus 3. And let's see what we've got here. If I distribute through, I get negative 1.5x. And if I do negative 1.5 times 3, I get negative 4.5. So that is the right answer. So moving that decimal over and making it so they don't have decimals in there, or thinking of it as if it didn't have a decimal in there, can be helpful. And I do just want to show you this. These are the warm-up questions right here. We just did these two problems and we're reverse. We've come full circle. So we distributed through to make this right here, and then I started with this right here and factored out to get right back to the original problem. Did the same thing with both of those, and that's really the idea. We want to be good at factoring things out. So if you'll take a look at example 2, you'll notice that we've got some fraction problems right here. So I'm going to do these a couple different ways. I'm going to think about this as if it didn't have decimals. So I'm going to think about this in terms of 15x plus 35y, and I'm going to think about what the common denominator would be, or sorry, what the common factor would be. So I've got a 15 and a 35. I could take out a 5, and I'm left with a 3x plus 7y. But remember, we're not talking about 15 and 35, we're talking about 0.15 and 0.35. So what I'd have to do in order to get this right is I'd have to move the decimal over 2 places here to make a 15 and 2 places here to make a 35. Well, in order to make this work out decimal wise, what I need to do is I need to move the decimal over 2 places. So what I'm taking out is, I'm taking out not a 5, but I'm taking out a 0.05 if I move those decimals over. So 3x plus 7y, and this right here is the answer. So we can do the same thing here, but I'm going to do this without moving the decimal. I am going to add a 0 there, so I have the same number of decimal places on both of those. And then I'm going to think in terms of, okay, 18 and 30, what number could I pull out? Well, I could pull a 6 out of both of those, but I'm not going to pull a 6 out. I'm going to pull a 6 with 2 decimal places in front of it. So if I move over 1 and 2, what I'm really pulling out is a 0.06. So if I divide this by 0.06, that would give me 3. And if I divide this by 0.06, that would give me a 5. Now, just to double check on the calculator, remember we're dividing out a 0.06. So on the calculator, here's what I'm going to do. I'm going to take 0.18 and I'm going to divide that by 0.06. And I get a 3. And we're going to take the negative 0.3 and we're going to, in fact, I'm going to even put the 0.30 and I'm going to divide that by 0.06. And that's going to give me that negative 5 right there. So a little bit of practice, you can get pretty good at these. Let's see, this is a negative 2.4x and a 1.6y, sorry, xy and a 1.6y. So I can take out the y for sure. And then if we were thinking, gosh, if this were a 24 and a 16, I could take out an 8. But remember, we've got one decimal place, so we're going to take out 0.8. And then this starts off with a negative, so I'm going to take out the negative also. So let's think about what we're left with. We took out the y, so we'd be left with an x. And I took an 8 out of a 24, or a 0.8 out of a 2.4. So that's going to be a 3, and we took the negative out. So this is going to start off with a positive 3x. If I take a negative out of a positive, that's going to make that the opposite of what it used to be. Think 16 and 8 here. If I take an 8 out of a 16, I'm left with a 2, and we took the y out. So I think this is the answer right here. But again, let's double check on the calculator just to make sure. So let's take negative 2.4 and let's divide that by negative 0.8. We get a 3. And we'll do the 1.6 and we'll divide that by negative 0.8. And we should get a negative 2 when we do, so we're in good shape there. Okay, let's take a look at this one right here. And again, the decimals can be a little bit tricky to work with. Nice to verify on our calculator, but let's do these fraction problems right here. So we've got 5/8 x plus 3/8. And again, if you say it, you can almost hear what the common denominator is. So the common factor would be that 1/8 right there. So we're going to take out an 1/8. There are no variables that are common right here, so that means we took out the 1/8, we're left with the 5 and the x, and if we took out the 1/8, then we're left with the 3. And you can see if we distribute back through, we would end up with that right there. Let's take a look at this one right here on E. We've got an asterisk by this for a reason. 20/3 y plus 4/3. Well, you can tell that we're going to take out a 3. We can take an 8 out of the denominators here and we were left with the 5 and 3. Here we've got a 3 in the denominators, so we're going to take out a 3. But take a look at the numerators. We've got a 20 and we've got a 4. Is there anything we can take out of the numerators? So if we take, let's see, a 20 and a 4, the biggest thing we could take out would be a 4. So we're going to take out a 4/3. So let's stop and think about it this way. We're going to take out the 3rd, so that's out. We're going to take a 4 out of a 20, so that means we're going to be left with a 5. Remember, we're dividing. So this is going to be a 5. We left the y alone. We took the 4 out and we took the 3 out. And remember, if we take everything out, there's always a 1 left in a multiplication problem. So there we go right there. So just to make everybody feel better, I'm going to pull this up on the calculator. And let's go ahead and type this in. Remember, we're dividing out a 4/3. So I'm going to do 20/3. And then we're going to divide that by 4/3. Now, it might not be a bad idea to put these in parentheses so we can see kind of what's going on. So I'm going to use that insert button just like you've got on your calculator. So I'm going to insert a set of parentheses here so we can kind of see what's going on. They're not absolutely necessary on something like this, but it's a good idea on a calculator like this. So we've got 20/3 and we're dividing it by 4/3. And we hit enter, and then there's the 5 that we get. And of course 4/3 divided by 4/3 would be 1, so we're in good shape there. Okay, let's head back over here. We've got a mix of what's going on here, and again, this is where it's going to be really helpful to recognize some of those common rational numbers. So we've got 2/3 xy minus, and then I'm going to treat this as a fraction, so 0.3 repeated would be 1/3 x. So 2/3 xy minus 1/3 x. You'll notice that we've got some thirds in common and an x. So I'm going to take out a 1/3 x. If I took out the third and the x, I'd be left with 2y. And if I took out the third and the x, I'd be left with, don't forget this, we're left with a -1. And then we can circle that. Now, it is possible to write this way. We could move that x on the top and we could write x over 3. That's the same as 1/3 x. And then 2y minus 1. That's a perfectly good way to write that. In fact, this, in many cases, this is actually better, but either way there is just fine as long as you're aware of the two of those. And then let's take a look at this one right here. 0.77w minus 7/10. And we've got to find a common factor for that one. So 0.77. Now, this one's a little bit tricky. This isn't repeating. Unlike that one, it's not repeating. So this is going to be 77 hundredths. I'm going to think of this in terms of fractions. So 77 hundredths w minus 7/10. Okay, so let's see. What can we take out? Let's see. First thing I might want to do is let's make these common denominators. So I'm going to multiply the top and bottom by 10. So then let's take a look here. And in the denominator, I can definitely take out 100th. We've got 77 hundredths w minus 70 hundredths w. Let's look at the numerator here. We've got 77 and 70. We can take out a 7 and nothing else. We don't have any common variables or anything like that. So I took out the 100. I took a 7 out of this, so that would leave an 11 and a w. And if I took the 100 out and if I took the 7 out, that would leave a 10. So that would be minus 10. So that would be the answer right there. We can also do this in decimal format. So if I kept it in decimal format, 0.77w minus 0.7, again, I'm going to do the same thing. I'm going to put a 0 there, so I've got the same number of decimal places. So I can think of this as a 77 and this is a 70. So I'm going to take out a 7. But remember, if I move that over 2 places, I've got to move this decimal over 2 places. So what I'm really taking out is a 0.07, because that's not really a 77, it's a 77 hundredths. So then we've got a w left here. Whoops. Look, gosh, if we take out the 0.07, that's going to be the 11. And again, I'm just going to double check that on the calculator. Sometimes it's easier to work with those fractions there. So let's see, if I take 0.77 and I divide by 0.07, yep, that's going to give me the 11. And then this should give me a -10. But again, let's just double check that on the calculator. -0.70 divided by 0.07. And there's our -10, just like we want there. So either way would be fine. Whoops. Either way is going to be okay, whether I write this as 0.07, which is 7 hundredths. There's the 7 hundredths right there. Fraction or decimal form would be totally okay. I do definitely think that the way to go on this one is fraction form on that one. So can you kind of get a sense as why we like to factor out the rational number form in expressions like this? So look what's left in parentheses in every single one of these. I realize it's a pain in the butt. I realize working with fractions and decimals, you're thinking, hey, can't we just leave these things the way they are? But I want you to take a look here. Look what's inside parentheses. 11w minus 10, 2y minus 1, 5y plus 1, 5x plus 3, 3x plus 7y, 3x minus 5, and 3x minus 2. What's left inside is a really nice expression with just integer numbers, and we tend to like working with those. So what we do is we kind of pull the nastiness out front, whether it's a fraction or a decimal, and then we leave the nice stuff inside, and that tends to work out well, and that's what you'd be expected to do on your assignment. So make sure you're looking for that greatest common factor, whether it's in fraction or decimal form, and pulling those out. Okay, thanks a lot.